Okay, so this video is going to talk about constructing confidence intervals or interval estimates for population mean. Remember, we denote population mean as mu, okay, representing the mean of all the possible individuals, okay? And we're going to look specifically at the case where sigma, that's our population standard deviation. We're going to look at the case where sigma is known. So let's just review a little bit of notation here. So we talked about alpha, okay? That's our error rate. So out of all the possible intervals that we could construct, there's going to be some error. Not all of them are going to contain the true population mean mu. We also tend to talk a lot about 1 minus alpha, which is our confidence. So again, out of all the intervals that we could construct, how many of those intervals would contain the true population mean mu. So that's sort of what's happening here when they're talking about this 100, 1 minus alpha % confidence interval. Pick your favorite error rate, let's say 5%, right? Then 1 minus alpha becomes 9.95, right? And so then 100 times 0.95 gives you the 95% confidence interval. So depending on the error rate you choose, this formula will change a little bit, but that's kind of what's going on. This formula, we can divide into the pieces that we had kind of already talked about. So we always start with our estimate, right? Our best guess, our point estimate of what the population parameter is. So in this case, if we're trying to estimate the population mean mu, our best guess is our sample mean, x bar. This next piece, I'll talk about what it means in a second. This is our critical value. Okay, I'll talk about that in just a second. And then this last piece, that's our standard error. Both of these pieces here make up what we call the margin of error. So let's go back to talking about that piece I kind of skipped over, this z alpha over 2, okay? So z alpha over 2 represents the value of the standard normal z distribution with alpha over 2 to the right. So it would probably help if I drew you a picture. Okay, so here's our standard normal distribution, our z distribution. It's a normal distribution with mean 0 and a standard deviation of 1, okay? And we're looking for the value here where this area to the right is alpha over 2, okay? And so the value that falls here, that's the value that we're sort of interested in. That's our critical value. So for example, okay, let's say I wanted a confidence level of 99%, okay? Then my alpha would be 1%, right? We've got 99% confidence. There's going to be a 1% error rate. Alpha over 2 becomes 0.05, okay? And then, okay, so that's our area to the right. Maybe I should write that in. This is the area to the right. Now, if we have an area, we can get a value using the code Q norm. But Q norm always likes, in the argument, this needs to be the area to the left. Why they made this so confusing, I don't know. But that needs to be the area to the left. So if we know this area to the right is alpha over 2, or in this particular case, 0.005, we can work out the area to the left. We know the area underneath the curve, the whole curve is 1. So this area has to be 1 minus alpha over 2. Okay, so I can work out 1 minus alpha over 2. In this case, it's 0.995. I plug that into Q norm and it'll spit out the critical value, 2.57. So in this particular case, this value here would be 2.57 if we wanted a 99% confidence interval, okay? And you can see that there's some other common ones that are given there. I tell students that those are probably good ones to have memorized because you're going to end up using them over the course of the semester. So being able to come up with the critical value for a 99% confidence interval or a 95% confidence interval quickly is going to help. But again, if you can't, you can always come back to these notes and look it up or use your brain to sort of figure it out for any confidence level that you might need. Okay. Another thing that, so we finished talking about the critical value. We finished talking about this piece, but let's just talk about this one for a second. So that standard error might look familiar, sigma over the square root of n. We talked about that sort of exact value when we talked about the central limit theorem, right? Remember that was the standard deviation of the distribution of x bar, okay? And so that's why that's getting plugged in there, okay? There'll be another video that should help you with understanding why that's there. Good. So just to sort of clarify how we interpret these confidence intervals, because this can get a little bit confusing. So remember, the whole idea of a confidence interval was for sort of these repeated samples, right? We were going to go out and sample one group and then do it again and again and again. So let's say we're doing that 100 times, right? Every time we construct a confidence interval, the confidence interval is going to be slightly different, right? And some of those confidence intervals might contain the true population mean mu, okay? And so in this case, that's our confidence, right? So 1 minus alpha percent of those samples will construct a confidence interval that's going to contain the true population mean, okay? You could think of that as there being a 1 minus alpha percent chance that, you know, we sample good enough data. We don't have a lot of weird outliers or anything, okay? What we have to be careful of is when we go through and just do one sample and construct one confidence interval, once we've gone through and constructed it and we've gotten actual values, okay, we don't say that there's a 95% chance that mu falls in there, because once it's already been constructed, there'll be values in there and mu is either going to be in there or it's not, right? It's probability 0 or probability 1. So it's only sort of in theory before we've constructed the confidence interval. We're talking about sort of in repeated sampling. If we were to do this over and over and over again, how many of the intervals will contain the true population mean mu? That's an important distinction to make, and it's a little bit tricky, I think, to wrap your mind around for the first time that you hear that, but we'll go over it again and again. And I'll give you some wording specifically that I hope that you use when you interpret confidence intervals. And again, that might be something you want to come see me in office hours. If you have any questions about, I'm happy to explain it as many times as I need to.